Hello everyone, welcome to the third video in the series. In this video we'll see this application running. Alright, so I flipped my Visual Studio. So the first thing you got to do is start the instances for Redis, MongoDB and Elasticsearch server. Alright, so let's run this batch file. Say yes. Alright, our Redis has started on 6379. MongoDB has started listening on port 27017, and Elasticsearch, let's wait for a couple of more seconds. Yeah, here it comes. It's running on 9200. Alright. Next you got to set matrix.web as your startup project and say run. Okay, this is the home page of this application. To access all these functionalities, I actually need to set up some lookup data. So you say yes, set it. So what this has done is, let me fire up Mongo Management Studio. In the meantime, we can fire our Elasticsearch head plugin as well. Okay, so there are no indices yet. Come on. Yeah, here it comes. So what has happened is, it has created the lookup data. Well, the lookup data is actually spread over 3 databases here. Say the first two, say employees and clients. If I go to employees, I say create a new one. So this is the lookup data I'm talking about. Say for gender, you have certain entries for programming rating, and same way for skills. So employees and clients go into business database, whereas product catalog lookup data goes into MX product catalog database, and the flag settings, or what are known as featured flags, we'll talk about it a bit later, goes into MX configuration. Alright, so you see that each of the collection here actually has an associated X collection, which is basically known as a history table in this case, or a history collection. So whenever a document is inserted into, say, the collection client type, the same document goes into history as well. Well, this is for auditing purpose. I've given full support for it. Alright, so let's just go to employees. Let's programmatically insert some 100 employees or so. So our employees are inserted. Alright, let's edit the first one. Let me give it a meaningful name, say Kelly McPherson. Let's set up a date of birth, say 1984. Alright, and let's say she knows core Java. Great, save. So the auditing tables that I was talking about, this is how it is actually used. You go to history link, so read it from bottom to top. So when the record was inserted for the first time, this is what its data was. Its version was 1, and there are other informations. So when an update happened, I mean, we changed her date of birth and her skills, so that got updated here. Auditing is basically a feature that is a business requirement in most of the enterprise applications, and the version increases to 2. Alright, so let's move next. And same way, I mean, we can perform CRUD operations on this. We can create a new employee, you can edit an existing one, you can even delete one. Say I'm deleting Max Payne 1, so it goes off the table here. And we have the associated history as well. This history is only to show you how these history collections are basically working. So let's just refresh this database. Alright, so we see this is an important feature of MongoDB. Whenever you insert a document, it will automatically create a collection for it. So the type here is employee, and if you take a look at any of the document, let's say the Kelly McPherson one, first one, so every document must have an ID, which is a must, and this is an auto-generated ID by MongoDB. It's a 12-byte unique string, and then there are other fields like name, version. Well, you can see that I've used some shorthand notations. Say for name I'm using NM, for version I'm using V. The reason being that each document in MongoDB actually carries its schema. Say in the same collection you can insert one more document that has a different schema than this, but that's not generally a good practice or a recommended one. Then we move to, so since each document carries its own schema, so if you give them shorter names, then the amount of space taken in memory is less, as we know that MongoDB keeps its working set in the memory. And then we have something like, say her gender is female, her rating is say average, skill is core Java. So this is where a document database actually shines. You can store your domain structure flat into the database. Say had it been done with a relational database, what you would have done is you would have stored the foreign key IDs for gender, rating, and skills would actually go as would have actually gone as a linked table, because there are multiple skills associated. Let's just add 2 more, say core Java and play framework. So let me just close this guy, reload. Alright, so now we should see 3 skill sets turning up: core Java and play framework. So this is the biggest selling point of a document oriented database, that you store your domain structure flat into the database. Alright, next we move on to say clients. Okay, clients here are not being directly inserted into the database. Here they are queued to the messaging middleware RabbitMQ, and it's the responsibility of a consumer application matrix.processor, and that would actually consume the message and put it into our database. Alright, so first thing we got to do is run this consumer. So it's listening for messages. So add a new client, say Monkey Corporation. I'm just giving some test data here. city sector, and let's have some test address, say create. Alright, so we do not see a record here, and that's because the front end actually published a message to RabbitMQ and immediately returned, so it does not care what exactly happened to the message. So it is the responsibility of the consumer that would actually process the message. So we see here that a new client has been created with a new ID, and this ID is given to us by the MongoDB ID generator. So if we refresh, we'll see that the record has actually been created. Well, this is how people actually scale. Say consider a case of, say, Amazon.com, where when you place an order, the application immediately returns to you saying thank you for placing your order, we'll be processing it shortly. So actually processing an order is a very heavy operation. Say it could involve saving your order and order items into the database, then an email would be shot to you saying that your order has been successfully placed. Subsequently, an email has to go to the supplier as well, which would actually supply your order items. So all that heavy stuff can actually be offloaded to messaging middleware that will take care of it. Alright, so next one is actually important. It is product catalog. Okay, in this product catalog we have got books only. So what happens here is when you add a new product, say a new book, it is first queued and inserted into MongoDB. MongoDB returns ID for the book, and then one more queue is fired to insert it into Elasticsearch, which is basically called remote procedure call for a request response async pattern. Alright, so let's just add some books programmatically here. So it has started processing many books for Mongo, which was complete, and then it started inserting all those search documents into the search engine asynchronously. Great. So let's just click on product catalog again. Alright, so we see our documents have been inserted. Let's go to MongoDB. Let's refresh. Let's go to product catalog. We have books here. Right. So all our books are created. I have actually inserted some data programmatically. I mean, first probably 10 some meaningful names so that I can search, and then rest all are like, say, some 5,000 records with some random number generations. Okay, so MongoDB has a feature called Mongo free text search. So let's search now. Let me say Java. So we see that some search results do turn up. Say a title with random book, some number, author is Max Payne, and the category is Java. Same thing happens with the second book, Java, but we see that the book with the title, with a meaningful title rather, has turned up third in this list. So what we do is we have actually inserted our data into Elasticsearch as well, right? I mean, this is where it will get interesting. So Elasticsearch, we see that 5011 search docs are there, which is the same count that was inserted in MongoDB. Alright, so what we do is we use something known as a featured flag setting. This is the way you roll out new functionalities in production. You experiment with existing stuff in production, and you induce new stuff as well. So I had programmatically created this setting, so let me just set it to true. So we saw that our searching is not up to the mark, so we ported it to search engine. Well, obviously a search engine, a full-fledged search engine is much more powerful in search compared to say MongoDB search or even any other search. So we go to product catalog, we see that our application is now using Elasticsearch engine. So let's search for the same term Java. Now we see the meaningful results do turning up. Say the title Awesome Java and building killer apps in Java is coming higher in the page. So this is how actually, and we can search with author names here. Say I say Paulo hello Paulo Coelho, yeah. So we see here the title has the highest weightage. Obviously that say the book with the title Java should turn up first, then a book which does not have title Java in it but it belongs to the category Java. So the same thing happens here, and it is followed by rest of the books where the author is Paulo Coelho but the titles do not match. Alright, okay, let's take a look at what do we have in our projects. Okay, so the source code here, this application consists of 6 projects. The heart of the application lies with matrix core. This is where all base generic repository patterns are defined for MongoDB, for even and for Elasticsearch engine, and for Redis distributed caching system as well. Then we have Del. Here we define database specific custom repositories, the functionality specific custom repositories, and custom repositories for say our book index as well. Then entities have entities defined for MongoDB and search docs for search documents, search docs for Elasticsearch engine rather. Business has our business domain structures and view models. Processor, this is the one that we ran here, right? This is the consumer applications for the messages published to RabbitMQ exchange, and matrix.web is our front end. Alright, so let's go to matrix core. So framework core here, I mean I have defined different, say for MongoDB we have a folder called Mongo core. For queuing or RabbitMQ we have a folder called Q core. Similarly for Elasticsearch and caching. So the framework core basically contains certain the most generic stuff, say the repository stuff. This is the repository, the database repository interface, which has the usual ceremony for CRUD operations, say insert batches, insert in bulk, then get one by ID, get many, update, delete, and other stuff. And this is implemented in, let's go to Mongo core. Here MX Mongo repository. Well, it does not directly implement the I repository or the generic repository pattern. It implements what is known as Mongo repository, which is a child to I repository, because this has the features which are specific to MongoDB, say bulk update, bulk delete, and other things like, say, inserting documents for auditing purposes. So let's take a look at insert method here. Important thing to note about here is write concern actually. So let's write concern means what way do you want your data to be written into Mongo database. Write concern. MongoDB. Just search for write concern in MongoDB. Oh, you should see this. Yes. Go to write concern here. Oh no, I've gone to the index actually. Okay, so write concerns are basically of 4 types. One is unacknowledged. That means you fire and forget. Acknowledged one is about, say, whenever you say insert an entity into a collection, this actually does not write it to the disk. MongoDB takes it into the operating system memory, and then from there on a periodical basis it is returned to the disk. Then there is journal. Okay, journal is a file which gives you a guarantee that your data would be returned to the disk, or if you go to data DB folder, you see this journal directory, right? So once your data goes into journal, and even if a power outage happens, and so nothing dangerous basically happens, because once it is returned to the journal, it will flow to these database files anyway when the power is back on. Then there is replica acknowledged. So we know that MongoDB works in master slave configuration, that is, it's a single master database, so it has many replicas, or what are known as replica sets. So you can achieve strong consistency by actually waiting for the control to return unless it is synced to replica sets as well. That means the secondary ones. Alright, so the same way I have defined repository patterns for Elasticsearch, so you can find it in IMX search or iSearch repository, which is being implemented by MX search repository. So here we have the usual stuff like, say, index, and index in an asynchronous way, then bulk index in async way, and then the reads, updates and deletes. And on the similar lines, the cache core stuff has also been defined, and that is where the Redis cache repository is implemented. So here we have methods for writing value types, writing the objects that are the reference types, and then reading them and deleting them. Alright, so you can go through the source code. It should be fairly simple to understand. I have also laid out a fair bit of documentation about it here, that is the architecture and usage, where I speak about that how do you create a new data access base repository for a database, you just inherit it from MX Mongo repository, and all your Mongo repositories must inherit from MX Mongo entity, and same way the search document should inherit from its own special class MX search document, and so on. So do let me know if you face any difficulty in setting up, say, any of these products, or running this application, or even understanding the source code. I'll be glad to help you. Last but not the least, it's important to note that say MongoDB or any other NoSQL database is not a magic bullet that could solve all your scalability problems in a day or two. You need to carefully think about your architecture and keep your application architecture flexible. Alright, so if you liked it, please share this application with this video series to other developers. Share it in your organization. You can contact me at my email address, which is amit.nosql@gmail.com, or feel free to write your questions as comments in this YouTube video. Well, thanks for watching. Thank you.